Dear students, welcome to physics class of P1. In the previous class, we have discussed about the contact and non-contact forces and what is the difference between contact and non-contact forces. So in this video class, I am going to explain here in detail about the contact force, that is the friction. So what is meant by friction? It is the property of a body by virtue of which the property by virtue of which the two surfaces in contact opposes the relative motion of the surfaces, right? So when we get the friction, so you may get the friction between the two solid surfaces or between the solids and fluids. Fluids are nothing but what? The gases and liquids together called as the fluids, right? So you have the friction between fluids and solids. Fluids andre endile gases and liquids together called as the fluids. So there may be a friction between fluids and solids right? There may be a friction between fluids and solids and solids, right? And also there may be a friction between the two fluids, that is between the liquids and liquids and between the liquids and gases. So we may have the friction between the two surfaces such as fluids and solids between fluids and solids and between two fluids, right? Here fluids is nothing but what? The gases and liquids together called as fluids. Gas ಮತ್ತೆ liquids ಎರಡನ್ನ ಕೂಡಿಸಿ ನಾವು ಏನಂತ ಕರಿತೀವಿ? Fluids ಅಂತ ಹೇಳ್ತೀವಿ, right? So there is in case of friction what happens? Which opposes, the friction is nothing but what here? It is a contact force. It is a contact force which opposes the motion of one body on the surface of another body. That is called as the friction, right? Now here in this class I am going to explain here in detail about the friction, that is the frictional force. What are the types of frictional force we have to discuss here, right? And one more point is what? The friction is a self-adjusting force. Friction is what? Self-adjusting force. What is meant by self-adjusting force? The friction is a self-adjusting force. That means what? When the applied force is equal to 0, the frictional force is also equal to 0. So this is the applied force. F is equal to 0. That is small f. This is the frictional force. So frictional force acts here opposite to the direction of applied force, right? So direction of force apply ಮಾಡಿದರೆ the frictional force opposite direction will act ಆಗ್ತದೆ. So when F is equal to 0, the applied force is equal to 0, the frictional force is also equal to 0. When the applied force is 0, right, the friction is also equal to 0. I have considered here one block on the surface here, right? Solid block you can consider here. ಇದನ್ನ ನಾವು ಮೂವ್ ಮಾಡಕ್ಕೆ ಟ್ರೈ ಮಾಡ್ತಾ ಇದ್ದೇವೆ by applying the force. When F is equal to 0, this frictional force is also equal to 0. applied force ಯಾವಾಗ 0 ಇರ್ತದ್ರಿ? ಅವಾಗ frictional force is also equal to 0. ಈ ಬಾಡಿ ರೆಸ್ಟ್ ಒಳಗದ ಅಂದ್ರೆ ಏನ್ರಿ? ಒಂದು ಸರ್ಫೇಸ್ ಮೇಲೆ ಒಂದು ಬಾಡಿ ಇಟ್ಟಿದ್ದೇವೆ, ಅದು ರೆಸ್ಟ್ ಒಳಗೆ ಐತಂದ್ರೆ ನಾವು ಏನೋ ಫೋರ್ಸ್ ಅನ್ನು ಏನೋ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ, ಅವಾಗ frictional force ಅನ್ನು ಏನಿರ್ತೈತ್ರಿ? 0 ಇರ್ತದೆ, right? As the applied force increases, the frictional force is also increases. ನಾವು ಯಾವ ರೀತಿ applied force ಅನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ, ಅವಾಗ frictional force ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತೀವಿ. And finally what happens if the force is applied is one direction? ನಾವು ಯಾವಾಗ ಫೋರ್ಸ್ ಒನ್ ಡೈರೆಕ್ಷನ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ ಅಂತಂದ್ರೆ ಅದರ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಒಳಗೆ ಏನಾಗ್ತಿದ್ರಿ? ದ frictional force will be getting here. That means what? If the force is applied in one direction, the friction acts in the opposite direction, and this frictional force is called as the passive force. Frictional force is called as passive force. What is meant by passive? Passive andre endile, that means when the applied force is removed or when the applied force is disappears, that means what? This frictional force also disappears. Now applied force ತೆಗೆದ್ವಿ ಅಂತಂದ್ರೆ the frictional force ಅನ್ನು ಹೋಗಿ ಬಿಡ್ತೈತೆ. ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? The frictional force is a passive force, and this frictional force disappears when the applied force is removed, and it can't make the body to move in the opposite direction. Now, applied force remove ಮಾಡಿಬಿಟ್ಟಿದ್ದು ಅಂತಂದ್ರೆ frictional force ಇರಂಗಿಲ್ಲ, ಅದು ಹೋಗ್ಬಿಡುತ್ತೆ. ಅವಾಗ ಈ frictional force body ಈ ಕಡೆ ಮೂವ್ ಮಾಡಂಗಿಲ್ಲ. So that's why it is called as what the frictional force is a passive force, and it is a self-adjusting force. Self-adjusting force ಅಂತಂದ್ರೆ ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈಡ್ ಫೋರ್ಸ್ ಇರಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಇರಂಗಿಲ್ಲ. ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಬೇಕು ಅಂದ್ರೆ ಫ್ರಿಕ್ಷನಲ್ ಫೋರ್ಸ್ ಬರ್ತೈತೆ ಅಂದ್ರೆ ಸೆಲ್ಫ್ ಅಡ್ಜಸ್ಟಿಂಗ್ ಫೋರ್ಸ್ ಅಂತ ಕರಿತೀವಿ ನಾವು ಇದಕ್ಕೆ. So now we have got that idea about the friction is a self-adjusting force and it is a passive force. Now what is the direction of contact force? That is also an important in this case. When the two bodies are in contact, that each body exerts a force on each other. According to Newton's third law of motion, that when one body is moving on the surface of the another body, or when two bodies are in contact, that each body exerts a force on the other body, and this contact force acts equal in magnitude and opposite in direction, and this need not be perpendicular to the surface. For example, ಈಗ ಒಂದು metal block ಅನ್ನು ತಗೊಂಡಿವಿ ಅಥವಾ ಯಾವುದೋ solid block ಅನ್ನು ತಗೊಂಡಿವಿ ಅಂದ್ರೆ this is placed on the other surface, and the two surfaces or the two bodies are acting the forces on each other, and that contact force need not be perpendicular to the surface. ಈ surface perpendicular ಆಗಿ ಇರಬೇಕಂತ ಏನಿಲ್ಲ contact force. It may makes an angle with the surface. ಆ surface ಕದು angle ಮಾಡಬಹುದು, right? For example, the contact force here acts in this direction. This is the contact force acting between the two bodies, right? Which need not be perpendicular to the surface. And this contact force between the two bodies obey the Newton's third law. Both are equal in magnitude and opposite in direction. So this is what the Fc is, the contact force between the two bodies, right? Fc is the contact force between the two bodies, which may need not be perpendicular to the surface in contact. And because of this, ಇಲ್ಲಿ contact force certain angle create ಮಾಡೋದ್ರಿಂದ horizontal ಗೆ ನಾವಿಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, we are resolving this contact force into two rectangular components. That means what? This one is called as normal reaction, and this one is called as, that is perpendicular to the surface, is called as the normal reaction. This is called as the normal reaction. It is denoted by the symbol N or R. Sometimes it is denoted by symbol N or R. It is called as the normal reaction, and the parallel force is called as what? The frictional force. It is called as what? The frictional force, F. So what we are getting the information from this point, the contact force need not be perpendicular to the what? The surface. The contact force can be resolved into two rectangular components. One is perpendicular to the surface and another one is parallel to the surface. Iದೇನು ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಇರ್ತೈತ್ರಿ ಎರಡು ಬಾಡೀಸ್ ನಡುವೆ, ಅದು ಸರ್ಫೇಸ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಇರ್ತೈತೆ ಅಂತ ಹೇಳೋಕ್ಕಾಗೋದಿಲ್ಲ. ಇಟ್ ಮೇ ಮೇಕ್ಸ್ ಎ ಸರ್ಟನ್ ಆಂಗಲ್. So then we are resolving this contact force into two components. One is perpendicular to the surface and another one is parallel to the surface. This parallel to the surface is called as the frictional force, and the perpendicular to the surface is called as the normal reaction, right? And the weight of the body acts in the downward direction. That is W is equal to M into G, and it is in the normal reaction is in the upward direction, and weight of the body which is in the downward direction. So when these two are balanced, the body is in the equilibrium state, and the frictional force is acts in this direction, and if we apply the force in this direction, that body moves, right? So this may be applied force. When the applied force is equal to 0, and the frictional force is also equal to 0, and weight of the body is equal to normal reaction. Under these conditions, the body is in the state of rest. When we apply the force, then the body starts to move, right? With all these basic introduction, now let us discuss here is about the point you have to understand here is what is mean by normal reaction. This is the very important point, and next we have to discuss about the laws of friction also, right? What is normal reaction, which is the perpendicular component of the contact force, right? Parallel component is what? The frictional force. Now let us discuss here about the next point, the types of friction. What are the types of friction we have to discuss here? One is the types of friction. There are three types of friction. three types of friction. So here we have to discuss about the three types of friction. First one is about the static friction, and the second one is about the limiting friction, and the third one is kinetic friction. So what is meant by static friction, what is meant by limiting friction, and what is meant by kinetic friction? Now let us discuss here one by one. Now let us discuss here the types of friction one by one. What is static friction, limiting friction, and kinetic friction? Frictional force is a self-adjusting force. Frictional force is a self-adjusting force. That means applied force is equal to 0. Frictional force is also equal to 0, right? And when the applied force increases, the frictional force also goes on increases, right? Now, what is meant by static friction? What is meant by static friction? The friction between the two bodies when they are at rest. ಈ ಬಾಡಿ ರೆಸ್ಟ್ ದೊಳಗೆ ಇದ್ದಾಗ ಅವ ಎರಡು ನಡುವೆ ಏನು ಫ್ರಿಕ್ಷನ್ ಇರ್ತೈತಿ, ಆ ಫ್ರಿಕ್ಷನ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್. ದ ಫ್ರಿಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಬಾಡೀಸ್ ವೆನ್ ದೇ ಆರ್ ಆಟ್ ರೆಸ್ಟ್ ಅಂಡ್ ದೇ ಆರ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ದ ಫ್ರಿಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದ ಟೂ ಬಾಡೀಸ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಅಂಡ್ ವೆನ್ ದೇ ಆರ್ ಆಟ್ ರೆಸ್ಟ್, that is called as what? The static friction, right? And what is meant by limiting friction? So ಈಗ ನಾವು ಬಾಡಿನ ಮೂವ್ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವೆ, right? ನಾವು force apply ಮಾಡಿದ್ಮೇಲೆ ನಾವು ಮೂವ್ ಆಗಂಗಿಲ್ಲ. Certain maximum applied force is required. After that the body starts to move, right? As the applied force, this graph shows you, as the applied force increases, the frictional force also goes on increases, right? The frictional force also goes on increases, and at a certain point, right, at a certain point we have the maximum value of static friction. We have the maximum value of static friction, and that maximum value of static friction is called as the limiting friction. What is meant by limiting friction? The maximum value of static friction between the any two bodies in contact, right? It is the maximum value of static friction. The maximum value of static friction, that is called as the limiting friction, right? The friction between the two bodies when they are in contact and at rest, that is called as the static friction. As the applied force goes on increases, the static friction also goes on increases, and at a certain point, right, the maximum value of static friction is called as the limiting friction, right? After that, if you are applying the force, e point ದಾಟಿದ ನಂತರ ಏನಾಗುತ್ತೆ, so ಇಲ್ಲಿವರೆಗೂ ನಾವು ಇಷ್ಟು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ವಿ, right? This is the applied force. F is equal to Fs. So ಇಲ್ಲಿವರೆಗೂ applied force is equal to static friction ಇರ್ತದೆ, right? Static frictional force ಇರ್ತದೆ. So after that, what you are applying the force, ಈ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸ್ಟ್ಯಾಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಆದ ನಂತರ ನೀವು ಏನು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತೀರಿ, ಅವಾಗ ಬಾಡಿ ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ, ರೈಟ್? ದ ಬಾಡಿ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ವೆಲಾಸಿಟಿ. ಅದಕ್ಕೆ ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂದರೆ ಬಾಡಿ ಯಾವಾಗ ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗ್ತದೆ ಸರ್ಫೇಸ್ ಮೇಲೆ, ಅವಾಗ ಏನು ಫ್ರಿಕ್ಷನ್ ಇರ್ತದೆ ಆ ಫ್ರಿಕ್ಷನ್ ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ, ರೈಟ್? when the body is at rest, that is called as the static friction, right? The maximum value of the static friction is called as the limiting friction, right? And the third one, the kinetic friction. The friction between the two bodies in contact when they are in relative motion. ಯಾವಾಗ ಮೋಷನ್ ದೊಳಗೆ ಇರ್ತಾವ ಅವಾಗ ಕೂಡ ಫ್ರಿಕ್ಷನ್ ಇರ್ತೈತೆ ಎರಡು ಬಾಡಿ ನಡುವೆ. ಆ ಫ್ರಿಕ್ಷನ್ ಏನಂತ ಕರಿತೀವಿ ನಾವು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. Body is moving with the velocity v, right? Static friction, limiting friction, and the kinetic friction. So all these three cases are represented in this graph here, right? As the applied force, when the body is at rest, right, applied force is equal to 0, then frictional force is also 0 here, right? When the applied force goes on increases, the static friction is also goes on increase, that is the static friction also goes on increases, and at a certain point you have the maximum static friction, right? At the maximum point we have the at a certain point we have the maximum value of static friction, that is called as limiting friction. One point aad nanತರ ಏನಾಗ್ತೈತ್ರಿ, if you apply the force the body starts to move. ಇಲ್ಲಿ ಬಾಡಿ ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ ಥರ್ಡ್ ಕೇಸ್ ಒಳಗೆ. ಇಲ್ಲಿ ರೆಸ್ಟ್ ಒಳಗೆ ಇರ್ತದೆ, ನಾವು ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀವಿ, ಬಟ್ ಏನಾಗತ್ತೈತ್ರಿ, apply force is not sufficient to move the body, right? At a certain point of the applied force we have the maximum value of static friction, that is called as limiting friction. After that you are applying the force, then the body starts to move with the velocity v, right? If the applied force is equal to the kinetic friction, right? ಯಾವಾಗ ಎರಡು ಬಾಡಿ ಮೋಷನ್ ಇರುತ್ತೆ ಅವಾಗ ಫ್ರಿಕ್ಷನ್ ಇರುತ್ತೆ, ಆ ಫ್ರಿಕ್ಷನ್ ಏನಂತ ಕರಿತೀವಿ, ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಬಟ್ ದಿಸ್ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ Fk is less than Fx max ಇರ್ತದೆ, ರೈಟ್? ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಗಿಂತ ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಏನಿರ್ತೈತ್ರಿ ಕಡಿಮೆ ಇರ್ತೈತೆ, ಅವಾಗ ಬಾಡಿ ಮೂವ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗಿರ್ತದೆ, right? So if F is equal to applied force is equal to kinetic friction, then the body moves with velocity v, with a uniform motion ಇರುತ್ತದೆ. If the applied force is equal to the what, the kinetic friction, then the body moves with the constant velocity. If F is less than, applied force is less than the kinetic friction, right? ನಾವು ಅಪ್ಲೈ ಮಾಡಿದಂಥ ಫೋರ್ಸು ಕೈನೆಟಿಕ್ ಫ್ರಿಕ್ಷನ್ ಗಿಂತ ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಏನಾಗ್ತದ್ರಿ, the body retards, ಅಂದ್ರೆ ಫೈನಲಿ ಇಟ್ ಕಮ್ಸ್ ಟು ರೆಸ್ಟ್, ರೈಟ್? ಇಲ್ಲಿ ಬಾಡಿ ಮೋಷನ್ ಇದ್ದಾಗ ಅದ್ರ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗೋದು ಬರ್ತೈತ್ರಿ, ಫೈನಲಿ ರೆಸ್ಟ್ ಬರ್ತದೆ. If the applied force is greater than the kinetic friction, then the body accelerates. ಈ ಕೇಸ್ ಫಸ್ಟ್ ಕೇಸ್ ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ, F is equal to Fk, it moves with the constant velocity. If F is applied force is less than the kinetic friction, then it retards, the disaccelerate ಆಗ್ತದೆ, finally it comes to rest. And if applied force is greater than the kinetic friction, then there will be acceleration we are getting. So these are the three important types of kinetic friction. These are the three important types of friction, that is static friction, limiting friction and kinetic friction, and this is the graphical representation of the frictional force versus applied force. So in this graph we are representing the three types of friction here. So this line represents the static friction, right? This maximum value of the frictional force is called as the limiting friction, and when the body starts to move after the limiting friction, then we have the kinetic friction, and the value of kinetic friction is less than the static friction, right? So in this way we have to explain about the three types of friction here. One is static friction, it is the friction between the two bodies in contact when they are at rest, and limiting friction, the maximum value of static friction when the two bodies the maximum value of the static friction between the two bodies when they are in contact. And third one, the kinetic friction, the friction between the two bodies in contact and when they are in relative motion, that is called as the kinetic friction. Now let us discuss here the two important points about the laws of friction. So let us discuss here the laws of friction. The limiting friction between any two bodies is independent of area of contact, right? It is independent of area of contact. So you can see in the figure here, we have the wooden block of weight W which is placed on the on the surface here in contact with the surface AB. This is the surface AB, right? We have the wooden block of weight W which is placed on the other surface, right? Now in figure 1 you can observe the contact of the surface area of this body. It is just the area contact right, of this length, right? And the area of contact of this wooden block on this surface is this one. So the area of contact is more than in this figure, is more in this figure than this figure. ಈ ಫಿಗರ್ ಒಳಗೆ ನೋಡಿದ್ರೆ ಏರಿಯಾ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಜಾಸ್ತಿ ಇದೆ ಸರ್ಫೇಸ್, ಈ ಫಿಗರ್ ಒಳಗೆ ನೋಡಿದ್ರೆ ಏರಿಯಾ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಕಡಿಮೆ ಇದೆ, ರೈಟ್? ಇಲ್ಲಿ ವರ್ಟಿಕಲ್ ಪೊಸಿಷನ್ ಒಳಗೆ ಇಟ್ಟಿದ್ದೀವಿ, ಇಲ್ಲಿ ಹಾರಿಜಾಂಟಲ್ ಪೊಸಿಷನ್ ಒಳಗೆ ಇಟ್ಟಿದ್ದೀವಿ, right? So what it says, the limiting friction between any two bodies is independent of area of contact. The maximum value of static friction is called as limiting friction. ನೀವು ಏರಿಯಾ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಎಷ್ಟು ಇದ್ರೂ ಕೂಡ ಅದು ಬಾಡಿ ಎರಡು ಬಾಡಿ ಒಳಗೆ ಏನಾಗಿದ್ರೆ ಸರ್ಫೇಸ್ ಟಚ್ ಮಾಡುವ ಏರಿಯಾ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇಲ್ಲ, ರೈಟ್. ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಸೇಸ್ ಹಿಯರ್. ದ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಬಿಟ್ವೀನ್ ಎನಿ ಟೂ ಬಾಡೀಸ್ ಈಸ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಫ್ ಏರಿಯಾ ಆಫ್ ಕಾಂಟ್ಯಾಕ್ಟ್. ಈ ಸರ್ಫೇಸ್ ಟಚ್ ಮಾಡಿದ್ರು ಅಷ್ಟೇ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಇರ್ತದೆ, ಈ ಏರಿಯಾ ಟಚ್ ಮಾಡಿದ್ರು ಕೂಡ ಅಷ್ಟೇ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಇರ್ತದೆ. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್ ಎಫ್ ಎಸ್ ಮ್ಯಾಕ್ಸ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಡ್ಯಾಶ್ ಮ್ಯಾಕ್ಸ್. ಸೊ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಈ ಕೇಸ್ದೊಳಗೆ ಎಷ್ಟು ಇರ್ತದೆ, ಸೇಮ್ ಲಿಮಿಟಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಕೂಡ ಈ ಕೇಸ್ದೊಳಗೂ ಇರ್ತದೆ. ಸೊ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಫಸ್ಟ್ ಲಾ ಆಫ್ ಫ್ರಿಕ್ಷನ್ ಹಿಯರ್, right. The limiting friction between any two bodies is independent of area of contact, right. Now let us see the next law of friction here. The second law of friction, that is the limiting friction between any two bodies is directly proportional to the normal reaction between them. So let us consider here a wooden block, right, which is placed on the surface of the table. Right, this is the surface of the table which is placed on the wooden block is placed on the surface of the table. So totally there are 4 forces are acting on it, right. This is the applied force is in this direction and the frictional force is in the opposite direction. The weight of the body which is in the downward direction, and the normal reaction which is in the upward direction. That is the force exerted by the surface of the table on the wooden block. So we have we have totally 4 forces here. One is weight of the body, weight of the block, that is in the downward direction, W is equal to mg, and force, that is the applied force, and the frictional force, both are in the opposite direction. And here W is equal to m, that is the weight of the body is equal to the normal reaction, right. Now according to the second law of limiting friction between any two bodies, according to the second law, the limiting friction between the any two bodies is directly proportional to the normal reaction between them. So ಈ case normal reaction, the limiting friction ಏನಿದೆ ನೋಡ್ರಿ ಅದು ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರ್ತದೆ. ಅಂದ್ರೆ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಇನ್ಕ್ರೀಸ್ ಆದಾಗ ಏನಾಗ್ತದೆ, the limiting friction also goes on increases. This is the what the second law gives us the idea about the friction here. That means the maximum value of the limiting friction is directly proportional to the normal reaction. As the normal reaction increases, the limiting friction is also increases. Now here we have to state one coefficient, that is called as the coefficient of static friction and the coefficient of the kinetic friction. So we have the two laws here. The first one is about the area of contact. That means what, the limiting friction is independent of the area of contact between the two surfaces. And the second law states what, the limiting friction between the any two bodies is directly proportional to the normal reaction between them. That means as the normal reaction increases, the limiting friction is also increases. So these are the two important laws in friction. So from this law, what we can write here, this Fs max is directly proportional to n, and this Fs max, that is the coefficient of the limiting friction is directly proportional to what, the normal reaction. So by equality sign we can remove this proportionality sign and we have to write mus into n, right. So this mus is equal to this Fs max divided by n. So what is Fs max? This is the limiting friction. This is the limiting friction, and this n is what, the normal reaction. N is what, the normal reaction. And this mus is called as what, the coefficient of the static friction. This mus is called as what, the coefficient of, this is mus is called as what, coefficient of static friction. Coefficient of static friction. Coefficient of static friction. So define the coefficient of static friction, right. It is a dimensionless quantity. It is the ratio of limiting friction to the normal reaction, right. It is defined as the ratio of limiting friction to the normal reaction between the two surfaces. Now again we can define here about the coefficient of the kinetic friction. So what is meant by the coefficient of kinetic friction? Again here what happens, Fk, that is the kinetic friction is directly proportional to the normal reaction between the two bodies. Fk is also directly proportional to the normal reaction between the two bodies. Then here we write Fk is equal to mu k into n. Therefore mu k is equal to Fk divided by n. So what is Fk? That is the kinetic friction, right? And what is n? That is the normal reaction. So what we can define here, mu k is equal to what? Mu k is called as what here? It is the coefficient of kinetic friction. Mu k is coefficient of kinetic friction, and it is defined as what? It is defined as what? The ratio of kinetic friction divided by normal reaction. It is defined as what? It is the ratio of kinetic friction divided by normal reaction. Therefore coefficient of kinetic friction is defined as it is the ratio of kinetic friction to the normal reaction between the two bodies in contact. So these are the important points what we have discussed related to the friction, right? It is a self-adjusting force and it is a passive force, types of friction, static friction, limiting friction and kinetic friction, right? And the graphical representation and the laws of friction, coefficient of static friction and the coefficient of kinetic friction, right? This mu s and mu k are dimensional less constant. You constant values irtava, dimensions irangilla, because we have the ratio, we are getting what? Here it is the ratio of same physical quantities. So it is a dimension less constant and it doesn't have any unit, right? So this is about the friction, and in the next video class we will discuss about the next points related to what? The topic laws of motion. Okay, thank you students.